Hi everyone, welcome to Integral Calculus. Today we continue with section 6.2 and we're going to take a look at volume by cross section. Number one, volume of a sphere. So let's say we have a sphere of radius r. To figure out the volume of sphere, we're going to cut our slide. And this is what a slide look like. Oh, is this a sample? This sample. This example, this has the volume base area multiplied to thickness. So in order to figure the base area and the thickness, we're gonna draw the x and the y-axis. Here we go. This would be the radius. The top half of the circle of radius r is y equal to root of r squared minus x squared. So the base area is y multiplied to root of r squared minus x squared. Square thickness is dx, and we have pi r squared minus x squared dx. Volume is, we add them up, add up these sample disk or cross sections. Integral from negative r to r. Pi r squared minus x squared dx. Notice that the function is even. I'm gonna call it say fx here is pi r squared minus x squared is even. It's even function, much better. We can have 2 pi on the outside, integral from 0 to r squared minus x squared dx, and so 2 pi r squared x minus x3 over 3 0 r. So this gives us the 2 pi r to the power 3 minus r cubed over 3. And then when we sub in 0, we have 0. So this gives us the 2 pi times 2 r3 over 3, which is 4 pi over 3 r to the power 3. Yay! And this is a nice volume formula of the sphere. 2, volume of cone. So this is the cone with height h and base radius r. In order to figure out the volume of the cone, first let's create the axis for it. So this will be the x-axis, and this right here, it would be the y-axis. Okay, cut out a cross section, and it would look like this. A cross section is just a sample disk. sample disk have volume V equal to base area multiplied to thickness. The base area here is pi, and then this is x, the smaller radius. So it's the pi x square times thickness is change in y, so dy. Okay, we can solve for x or write x in terms of y because the thickness is dy using, well, look at this one. This is a right triangle, and then right here is also a right triangle. So we have a smaller right triangle inside a bigger right triangle. That means we're gonna use similar triangles. X over I'm gonna call this point right here y, because that's on the y-axis. The distance between the top and y is the height h minus y. Yeah. So x over h minus y equal bigger radius divided by bigger height over h. We have x equal to r over h minus y. Yay! And so from here, x squared is pi r square over h square h minus y square we have the volume of sample disk. So now to find the volume of the cone, we just add them up. And when we add them up, that is the integration. Integral from 0 to h. Pi r square over h square h minus y square dy. Now, gonna use the use up here. U equal h minus y. du is negative dy. From here we see that the upper limit is h minus h 0. Lower limit is h minus 0 is h. And this would become integral from h to 0. Pi r square over h square multiply to u square negative du. Well, we can switch the limit and get rid of the negative, and we will have pi r square over h square integral from 0 to h u square du. This is nice. Pi r square over h square, the antiderivative is u3 over 3, and ta-da! Evaluate from 0 to h, we have pi r square over h square multiplied to h3 over 3, which is ta-da, pi r 1 over 3 pi r square h, and this is volume of a cone. Awesome. Let's move on. Volume of frustum. So a frustum is a cone, and we're gonna cut out a part of it. So how do we figure this out? We have two radius, a smaller radius and a bigger radius, and the height h. So from here, we got to do a little trick. And that trick is gonna connect this together to get the y-axis there. This is going to be the y axis. Right. We also gonna have this line right. See this part right here. That I'm gonna draw the line right here. This side is the difference between the bigger radius and the smaller radius. So r minus r. Now we're gonna sketch out cut out a cross section. Let's do the cutting. This is what a cross section look like. It's again a sample disk. Okay, so this sample disk has volume of base area multiplied to thickness. Base area here is, of course, pi, and then the radius square. The thickness is the dy. The radius here, as you see, is the smaller r plus this distance. I'm gonna call it x right here. Yeah. So it's r plus x square. Similarly, you can say that, oh, we have two right triangles, right? Smaller one and a bigger one. So we can use a right triangle all over again. And using the same trick, I'm gonna let this point to be this point right here to be y. So the height of the smaller rectangle is h minus y. Similar triangle. X over h minus y equal to the bigger radius minus the smaller radius over h. From here, we see that x is bigger radius minus smaller radius over h times h minus y. Yay, plug it in. And we have pi r plus r minus r over h minus y square dy. Well, we can distribute and work out the algebra to get pi, the bit r minus r over h over r over h times y square. Yeah. Dy. Okay, this is good enough though. Now the volume of the frustum is going to be the integral from 0 to h pi r minus r over h times y square dy. Use the u sub. Use equal r minus r over h y. So du is gonna be a minus r over h dy. So dy is negative h over r minus r. Okay, we have to also change the limit here. The upper limit is the you let y equal to h, then you're gonna get the smaller r. The lower limit is let y equal to 0, then you get the bigger r. Do the u sub, and we have bigger r to smaller r. In his pi u square multiply to if you solve for dy, then it'll be a negative h over r minus r du. Okay, we can get rid of the negative by exchange the limit of the integral, and because the integration depend on u, you can pull all the constant multiple outside. Pi h over r minus r, integral from r to r, u square du, and this would get us pi h over r minus r. This would be u to the power 3 over 3, integrate from r to r. Okay, so now do the substitution, and we have pi over 3 h over r minus r, r3 minus the small r3. Oh, we got to factor this out, so pi over 3 times h over r minus r. This factor will be r minus r squared plus r plus the small r square. Do the cancellation, and ta-da! What we have next is the volume of the frustum. Pi over 3 h, the bigger r square plus the smaller r times the bigger r plus the smaller r square. Pretty cool, huh? Okay, one more example. Volume of pyramid. In the pyramid here, if you take a look, the cross section is a square. So that means a sample slide here. Sample slide. It has volume of, well, as you can see, base area times thickness. And the base area is, okay, we can let this to be S here, this side. So S square, thickness is just a small change in y, so dy. We got to figure out that S. Oh, luckily, hopefully, you guys see that we have a two triangle here, one inside another. So we have a smaller triangle, which is this one. And then we also have a bigger triangle, which is just this one. Down here, I'm gonna call it L. L is the base side of the pyramid. Similar. Triangle. S over h minus y equal L over h. So this tells us that S is L over h times h minus y. And so S squared is gonna be L squared over h squared, h minus y squared. Yay! We have volume of a sample slide. To figure the volume of the pyramid, we just add them up. And that is the integral from 0 to h of L squared over h squared, h minus y squared dy. Okay. Similarly, use the u sub. U is h minus y. Du is negative dy. And then the upper limit is 0. Lower limit is h. This would be integral from h to 0. L squared over h squared u squared times negative du. Switch the limit and get rid of the negative. Integral from 0 to h L squared over h squared u squared du. The antiderivative is u3 over 3, and then we can put a constant multiple outside. So we have a L squared over h squared times u3 over 3. Evaluate from 0 to h. And this gives us L squared over h squared times h3 over 3, which is 1 over 3 L squared h. And that is the exact volume of the pyramid having height h and the base side L. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I will see you in the next video.